we asked an independent laboratory to have Airwear lenses undergo a particular impact test. The experiment you see here is a ballistic test. A small ball is thrown out of this machine at high speed and runs into the lens. We start the test with glasses fitted with standard plastic lenses. The lens breaks, which means in case of a projectile such as a stone hitting the lens, the wearer would be injured. Let's now do the same, but with glasses fitted with Airwear lenses. The lens resists perfectly. With Airwear, our eyes are protected from injury. How can we explain such a result? Airwear, as a polycarbonate lens, is reacting like a shock absorber. As you can see in slow motion, the lens becomes warped under the impact. While the lens is damaged, it doesn't break, compared to a standard lens.
Okay, let me show you something. Here is a white cloth that was soaked in photosensitive pigment. Now let's place different kind of lenses on the cloth. A mineral lens, a standard plastic lens, and an Airwear lens. Now let's expose the cloth with the 3 lenses to UV rays. Ready? Let's start. Under UV rays, the cloth turns gray. But if the lens blocks the UVs, the cloth won't be activated and remain white. Now look. Under the mineral lens, the cloth turned completely gray, the same intensity as areas not covered with lenses. Under the standard plastic lens, the cloth turned light gray. The UVs were not totally blocked by the lens. Now let's see how the Airwear lens reacted. The cloth remained white. Airwear lens is 100% UV cut. The AVI number, not an easy subject. Often judged as representative of the optical quality, the AVI number gives rise to a lot of misinterpretations by the ECPs. Its value for Airwear is 31, like the high-index materials. Let me ask you, can millions of polycarbonate and high-index wearers all be wrong? It's doubtful.
The RB number relates to chromatic dispersion. In static vision, eye movement is done in a maximum angle of 30 degrees, which means wearers use a central part of their lenses and are not affected by chromatic dispersion. When they perceive something outside of this angle, they automatically turn their heads. Airwear is recommended for low and medium prescriptions. Only high prescriptions wearers for whom Airwear is not recommended could perceive aberrations on peripheral vision.
So if there's chromatic aberration at a point on a lens where no one looks, is there a problem with optical clarity? Millions of polycarbonate and other high-index lens wearers have already answered. No.
Airwear's low density and its refractive index of 1.6 results in a very thin lens that is very lightweight. Here are 2 columns filled with salt water, and this is a standard plastic lens. Let's release it. We see it sinking deeper and deeper. Let's do the same with an Airwear lens. Airwear floats as a result of its low density. Conclusion: Airwear is lighter than a standard lens, more accurately 30% lighter.